Hello everyone, this is Pawan and I have with me Janmejay.
Hi.
In this video we will be talking about the basics of test load balancer and the problem that it tries to solve. In front of you, you have the agenda for this video. Let's look at the problem that TLB tries to solve, which is slow builds. How does a slow build affect a project, right? Typically if a project has a slow build, the first thing that gets affected is the number of check-ins that happen in a day. Typically when builds are running, a team has to wait to check in, and this means that if a build is slow, the number of check-ins that happen in a day is less. And obviously as the number of check-ins reduce, the number of productive work that is getting done is also less. Another problem is if a build breaks, as it typically happens, the entire team gets blocked for a long time. This is because only the person who broke the build will be checking in the fix for the broken build, and until the time that the build goes green, the entire team is blocked for checking. And this is again a problem because the build is slow. Another not so obvious thing that gets impacted is the lead time to deployment. Most of the times you would want to deploy a build for manual regression or a sign-off only when it is validated by all the automated tests in the project. And if this takes a long time, the act of deployment to an environment where the manual testing happens also gets affected. And this does not happen often, and hence there will be a big gap in terms of feedback of a given build. So all in all, slow builds have a very costly impact on a project, and this should definitely be solved. Now let's look at why a build is slow. Typically in our experience, builds are slow not because of the actual building of a shared object or building of a binary, but it is actually slow because of the validation of the artifacts of a build. What we mean to say is, if you are on a Java project and you want to get a binary, that is a jar, out, the actual act of building the jar is not what takes time, but the act of validating the jar and validating that it does the right things is what takes time. You would want to run your unit tests, integration tests and functional tests and make sure that the behavior is right, and that is what takes time. So builds are slow most of the times because of that. That doesn't mean that there are no other reasons for why a build is slow, but in our experience 80% of the cases that is why a build is slow. Now let's look at a potential solution for how to fix this problem. Now one of the solutions that we want to address in this video is parallelization. Again, there are multiple ways of solving this, but we want to talk about this because of the nature of this solution. Now the biggest property that we can leverage of a test is the fact that it is independent. Tests should be written in a way such that they are independent of each other, so that a given test output can be trusted. If there are dependencies, then the trust in the test would automatically go down. Given this makes test an ideal candidate for parallelization, because we can start executing them in parallel, knowing for a fact that they would work properly, and hence you would want to parallelize it. How we would actually parallelize this and what would you use for it is what Janmejay would continue in the rest of this video.
So we have a little case study here. So this is the data that so this data is captured from the project that we work on, and this is a 4-year-old product, and so you can imagine that within 4 years, a lot of features have been added, a lot of bug fixes have been done, and a whole bunch of tests are written for it. So this is for our dev build. Our dev build runs unit and integration tests, and our dev build is would be 2 hours and 7 minutes if we run it serially. So this is the length of our dev build run serially, but we make 16 partitions of it. So there are 16 processes running parallelly. And it takes about 9 minutes and 2 seconds to finish our build. I'm going to show you how it looks in the real world. So this is an image from our build tool, and it says one job. So this thing that you're seeing here right under my cursor is a job, and that runs our tests. And it takes about 2 hours, 7 minutes, and 25 seconds to run the whole suite. Whereas if you make 16 partitions, you have to take my word for it because the font is really small, but it's 16 parallel partitions, and the build actually finishes in just 9 minutes and 2 seconds. That's a big jump from 2 hours and 7 minutes. And of course, this can be increased further. If you increase the number of partitions further, we can actually bring down the build time even more. So the next thing I'm going to show you is the functional build. So these are our functional tests that use the browser. So they actually drive the application from a real web browser, and hence they are time taking because it's like a user driving functionality. And you can see that we have 9 partitions here, and 42 minutes is about the time when the job's all finished. And you can see here that the duration was 42 minutes and 3 seconds right here. So let's do a little bit of math and let's see what that means. This means that I'm running 40-minute builds. I'm running 9 of them. If I was running it serially, it would finish in 6 hours, right? So 60 minutes in an hour, it's a 40-minute build, 9 partitions, simple, right? Now let's go a little bit further and let's see what are the implications of having 2 hours and 2 hours and 7 minutes dev build and a 6 hours acceptance build on a team. Right, so it's an 8-hour day, so I just divided by the number of minutes. So you can see that overall build length is actually more than a day. This means if I have the build failing in the morning, and if I check in the fix within a few seconds of coming to the office, even then I have to wait for a day before I can get a good build out, before I know that all my tests have passed with the bug fix that I've patched into the code base, right? So this is really bad, which means I only get like 1 valid good build out per day. Even if my build does not fail, that's my rate. So that was a little case study of using TLB on a real world project. Now let's get into what TLB actually does. So one of the things that we want to add here is that the property of tests that allow them to be parallelized is that they're independent of each other. You should not make tests dependent on each other. And yeah, as long as your tests are independent, they can be run in parallel on different machines or on different VMs or whatever. So I'm going to introduce you to TLB. I'm going to tell you a little bit of how TLB works. So imagine that you have a grid of X number of machines, right? Say like you have a grid of say 5 machines, and you want to make 5 parallel partitions of your build. So the time of the length of the build reduces by 5 times. So what do? You would if you just run and test or make test or say rake test or whatever test task on all these 5 machines, the effect of that is going to be the whole test suite executed on each one of these machines, which means the build length remains the same, right? So that's not what you want. You want an agent that sits in your build, in between your build tool and your testing tool, which can actually decide a unique set of tests to run on each set partition. So I have 5 machines. I run my build on each one of these, but this agent that sits with my build actually decides that a certain test has to run on the first machine, whereas another one has to run on the second machine, and so on and so forth. So what TLB does is it runs a mutually exclusive and collectively exhaustive set of tests on each such machine. So which means no tests are repeated and no tests are actually missed out. So you're getting complete validation on your build while you're running all the tests in parallel on different physical machines or multiple processes on the same machine or multiple VMs and one process inside each or whatever setup you like. So that's what TLB actually does. So you can continue watching this space. So here's the link to the TLB website. We have a channel on YouTube. You can continue watching this space for more on how to integrate TLB with some of the popular build tools and some of the popular testing tools. And we're also going to talk about the TLB concepts and how can you configure TLB, tune it to your taste and all of that. So continue watching this space for more. Until then, happy hacking and thank you.